July 24, 1943, 120 miles west of Truk Lagoon. The periscope lens misted slightly as Lieutenant Commander Lawrence Randall Daspit observed something that would upend every assumption the U.S. Navy held about its primary undersea weapon. Through the reticle, a 19 to 262-ton Japanese tanker lay dead in the water, crippled, helpless. The largest prize a submarine skipper could hope to encounter. He had already struck it twice with torpedoes, 2 textbook detonations that disabled the vessel's engines. Now came the expected finishing blow, a point-blank shot at a right angle, the geometry of perfect submarine attack. What Daspit recorded over the next hour would expose the greatest weapons scandal in American military history, a systematic failure so severe that submariners had been sent into combat with ordnance that functioned only about 20% of the time. For a year and a half, the U.S. Navy had prosecuted the Pacific War with defective torpedoes. Sailors had been dying needlessly. Japanese convoys sailed with impunity, and the officials charged with fixing the problem blamed the crews. On this day, one commander would gather evidence so damning that even the Navy's most entrenched bureaucracy could no longer deny the truth. The Mark 14 Canon 14 torpedo, America's most advanced weapon of its kind, was fundamentally flawed, and it would take one man's dogged investigation, launched against orders and at considerable personal risk, to correct it. The cost of bureaucratic negligence was being counted not in dollars, but in ships unsunk, sailors lost, and a war prolonged. The arithmetic of victory was being rewritten off Truk, and Lawrence Daspit was about to supply the proof that would change everything. The nightmare began on December 8, 1941. Hours after Pearl Harbor and Admiral Chester, Nimitz's order for unrestricted submarine warfare against Japanese shipping, the U.S. submarine force went to war confident. They carried what they believed to be the finest torpedo in the world, the Mark 14, developed at the Naval Torpedo Station in Newport, Rhode Island. It was an engineering marvel, 20 feet 6 inches long, 21 inches in diameter, about 3,000 pounds of precision mechanisms, capable of running 4,500 yards at 46 knots or 9,000 yards at a reduced speed of 31 knots. Each torpedo cost roughly $10,000 in 1931 dollars, the equivalent of about $180,000 today, more than the price of a dozen automobiles. This was not a commodity to squander in testing. The Mark 14 carried a 653-pound Torpex warhead, but its true innovation was the Mark 6 magnetic influence exploder. Developed in strict secrecy beginning in 1922, the magnetic detonator was designed to explode beneath a ship's keel where armor was absent. The underwater blast would create a massive gas bubble and theoretically break a ship's back. One hit could sink a battleship. The Navy's confidence was such that it conducted only 2 live-fire trials, both on May 26, 1926. The first test failed completely. The torpedo ran under the target without detonating. The second succeeded, intentionally destroying the decommissioned submarine L-8, which had been struck from the Navy list for the purpose. Then, for 17 years until December 1941, not a single additional live trial was held. The reason was simple. Torpedoes were expensive. The Great Depression gutted military budgets. Congress slashed Navy spending throughout the 1930s. Newport employed some 3,000 workers running 3 shifts, yet produced barely 1.5 torpedoes per day. Backlogs mounted. By January 1938, unfilled torpedo contracts totaled $29 million. There was neither money nor inventory for destructive testing, so the Navy relied on practice heads that floated when fuel ran out. These practice torpedoes were recovered, inspected, and declared flawless. The magnetic exploder was tested in laboratory tanks of still water with perfect results. The Bureau of Ordnance pronounced the Mark 14 ready for war. But ordnance proven in tanks and with dummy warheads does not always behave the same in combat. On December 24, 1941, just 16 days into the war, Commander Tyrell Dwight Jacobs of USS Sargo fired 8 torpedoes at 2 Japanese merchantmen. 0 hits, 0 detonations. Jacobs was certain his fire control solution was correct. He had tracked one target for 57 minutes to ensure his calculations matched before firing, yet 8 torpedoes produced nothing. A week earlier, on December 14th, USS Seawolf had reported torpedoes running much deeper than their set depths, estimated 10 to 15 feet beneath the targets, too deep for the magnetic exploder to sense the hull and too deep for contact fuses to activate. Reports multiplied. USS Sargo recorded the first premature explosion just 1 week after Pearl Harbor. A torpedo had exploded halfway to its target. USS Skipjack, USS Stingray, USS Sturgeon. From every patrol area, submarine commanders sent the same message. The torpedoes were not working. They ran too deep. They exploded prematurely. They failed to explode at all. Or, most terrifyingly, they decircled back toward their own submarines. By June 1942, American submarines had fired over 800 torpedoes in combat. 80% had failed. 8 out of every 10 torpedoes fired at the enemy either missed, malfunctioned, or failed to detonate. The mathematics were devastating. American submarines should have been destroying the Japanese merchant marine. Instead, Japanese convoys sailed largely unmolested, while American submariners risked their lives with weapons that didn't work. The submarine commanders knew something was fundamentally wrong. They sent detailed reports to their superiors. They documented every attack, every malfunction, every failure. They requested investigations. They demanded tests. The response from the Bureau of Ordnance was consistent and insulting. The problem was not the torpedoes. The problem was the submarine commanders. They were making poor approaches. They were miscalculating firing solutions. They were failing to maintain the weapons properly. The Bureau of Ordnance had designed the Mark 114. The Naval Torpedo Station had built it. 2 decades of engineering had gone into its development. The fault could not possibly lie with the weapon. The fault must lie with the men using it. At Pearl Harbor, Rear Admiral Thomas Withers, Commander Submarines Pacific, consistently sided with the Bureau of Ordnance. When his submarine commanders complained about torpedo failures, Withers blamed their lack of initiative. The expensive torpedoes were in short supply. They could not be wasted on field testing. Boer had declared the weapons sound. That was the end of the discussion. But one man was listening to the submarine commanders, Rear Admiral Charles Andrews Lockwood. Born in Midland, Virginia on May 6, 1890, Lockwood had graduated from the United States Naval Academy in 1912. His submarine career began in September 1914 when he reported to the tender USS Mohican for submarine training. By December 1, 1914, he commanded USS A2, the Navy's second submarine. Lockwood had spent nearly 3 decades in submarines. He understood the men who commanded them. He knew they were reporting genuine problems. When submarine commanders with years of experience all reported the same failures, Lockwood listened. In May 1942, Lockwood became Commander Submarines, Southwest Pacific Area, based in Fremantle, Australia. He immediately found himself dealing with the Mark 114 controversy. His submarine commanders were reporting catastrophic failure rates. Japanese ships were escaping. American submarines were accomplishing almost nothing, despite taking enormous risks. Lockwood knew Buard would never authorize official testing. The torpedoes were too expensive. The supply was too limited. But Lockwood also knew that sending men into combat with defective weapons was infinitely more expensive than testing. In June 1942, Lockwood did something unprecedented. He ordered unauthorized tests of the Mark 114 torpedo against Bureau of Ordnance regulations without permission. At risk to his career, he was going to find out if the torpedoes really ran deep. Captain James Fay, Lockwood's chief of staff, devised an ingeniously simple test. They would fire torpedoes through fishing nets suspended at known depths in Frenchman Bay near Albany, Australia. On June 20, 1942, USS Skipjack fired a single torpedo with an exercise warhead from 850 yards. The torpedo was set for a depth of 10 feet. It should have pierced the net at 10 feet. Instead, it ripped through the net at 25 feet, 15 feet, 10 feet deeper than the setting. The next day, James F. supervised 2 more test shots. Both torpedoes ran 11 ft deeper than set. The evidence was conclusive. The Mark 114 ran dangerously deep. Lockwood immediately reported his findings to the Bureau of Ordnance. Their response was swift and dismissive. No reliable conclusions could be drawn from Lockwood's tests. The fishing net method was not scientifically valid. The submarine commanders must have trimmed the torpedoes improperly. Lockwood repeated the tests. 3 torpedoes set at 10 ft cut the net at 21 ft, 11 ft deeper than the setting. Still, the Bureau of Ordnance refused to accept the evidence. Their tests at Newport showed no depth problems. The fault must lie with the submarine force. Admiral Ernest Joseph King, Chief of Naval Operations, had heard enough. King was not a man to tolerate bureaucratic nonsense. He ordered the Bureau of Ordnance to conduct their own tests immediately. In July 1942, the Bureau finally tested the Mark 14 at Newport. In August 1942, more than 8 months into the war, the Bureau of Ordnance officially admitted that the Mark 114 torpedo ran 11 ft deeper than set. Torpedo ran 11 ft deeper than set. The cause was a nested series of design flaws. During development, the torpedo had been tested with lightweight exercise warheads. When loaded with heavy combat warheads containing 680 Alkylbov explosive, the torpedoes naturally ran deeper. But that was only part of the problem. The depth control mechanism used a pressure sensor to measure water depth. During testing, this sensor had been placed in the torpedo's conical tail section. At 46 knots, water flowing past the conical shape created a low-pressure area. The pressure sensor incorrectly interpreted this as shallow depth and directed the torpedo to dive deeper. The faster the torpedo traveled, the deeper it ran. This problem could have been discovered with a single test using a full warhead, but that test was never conducted because torpedoes were too expensive to destroy. By August 1942, the depth problem was identified. The Bureau of Ordnance issued new instructions for calibrating the depth mechanism. Submarine commanders began setting their torpedoes to run at 0 depth to compensate for the 11 feet anti-FT error. The Navy believed the torpedo problem was solved. It was not. With the torpedoes now running at the correct depth, a new problem emerged. Premature explosions. Torpedoes were exploding before reaching their targets. The explosions occurred hundreds of yards short of Japanese ships. Submarine commanders watched through their periscopes as torpedoes detonated harmlessly in open water. The magnetic exploder was firing too early. On April 9, 1943, Lieutenant Commander John A. Scott in USS Tunney found himself in a perfect attack position. 3 Japanese aircraft carriers, Hio, Juno, and Taiyo, range only 880 yards. Point-blank range for a submarine attack. Scott fired all 10 torpedo tubes. He heard 7 explosions, but none of the carriers slowed. None showed damage. All 3 continued at full speed. Intelligence analysis later revealed that all 7 torpedoes had exploded prematurely. The magnetic exploder had triggered too early. Not one torpedo had reached its target. On April 10, 1943, USS Pompo attacked Japanese aircraft carrier Shukaku with 6 torpedoes. At least 3 exploded prematurely. The carrier was undamaged. On June 10, 1943, USS Trigger fired 6 torpedoes at aircraft carrier HEO from 200 wide. 1 missed cleanly, 1 exploded prematurely, 1 was a dud. 2 hit and caused minor damage. The carrier survived and limped home. The pattern was undeniable. The magnetic exploder was unreliable. On April 27, 1943, the Bureau of Ordnance finally admitted the Mark VI exploder was susceptible to premature explosions at shallow depths. The Bureau recommended disconnecting the magnetic feature in favor of contact shots, but even this admission came with conditions. The Bureau wanted to increase the arming distance from 450 yards to 700 yd. They wanted submarine commanders to fire only under specific conditions that would minimize premature explosions. Admiral King rejected the increased arming distance. 700 wide was unacceptable. Submarines needed to get close to their targets. King agreed with Lockwood. The magnetic exploder should be disabled. On June 24, 1943, Admiral Chester Nimitz ordered all submarines in the Pacific Fleet to deactivate the magnetic influence exploder. Use only the contact exploder. 18 months into the war, the Navy finally admitted that the magnetic exploder was a failure. But the Bureau of Ordnance's problems were designed into the weapon from the beginning. The magnetic exploder was so secret that even submarine commanders were forbidden to examine it. Bureau of Ordnance regulations required torpedo shops to apply dabs of paint to the screws holding the exploder mechanism. Any tampering would mar the paint. Submarine commanders were literally prohibited from examining the weapon they were risking their lives to use. But submariners are an independent and resourceful group. Torpedo men in the submarine bases would ask the paint shop what color paint was being used. If told blue, they would acquire small cans of matching blue paint. They would open the exploder mechanisms, make their own modifications, then carefully repaint the screw heads. When torpedoes were returned to the official shops, there was no evidence of tampering. By mid-1943, submarine commanders across the Pacific were quietly disabling the magnetic exploder on their own. They were doctoring their patrol reports, overstating the size of enemy ships to justify using more torpedoes. They were lying to their superiors because the alternative was dying for nothing. Only one area commander insisted that his submarines continue using the magnetic exploder. Rear Admiral Ralph Waldo Christie, Commander Submarines, Southwest Pacific Area. Christie had been the officer in charge of developing the Mark VI magnetic exploder in the 1920s and 1930s. He had spent years perfecting the device. He had staked his reputation on its success. Despite mounting evidence of failure, Christie refused to believe his creation was flawed. He ordered his submarines to continue using the magnetic exploder. His submarine commanders were furious. They watched their torpedoes explode prematurely or fail completely, while submarines under Lockwood's command, operating with the magnetic feature disabled, were finally achieving success. Christie's boats continued to suffer catastrophic failure rates, while Lockwood's boats began sinking Japanese ships. It would take a direct order from Admiral Thomas Kincaid, Commander Allied Naval Forces Southwest Pacific Area, in November 1943 to finally force Christie to disable the magnetic exploder in his area. But even with the depth problem fixed and the magnetic exploder disabled, torpedoes were still failing. Now, submarine commanders reported a third problem: duds, torpedoes that hit Japanese ships and failed to explode. On July 24, 1943, Lieutenant Commander Lawrence Daspit in USS Tenosha encountered the target every submarine commander dreamed of finding, a 262-ton tanker. Alone, unescorted, code rears had provided advanced warning of the ship's route. Tenosha was perfectly positioned. At 0555, Daspit spotted Tonin Maru No. 3 heading directly toward him. At 0928, Daspit fired 4 torpedoes from 4,000 watt. His son heard 4 distinct thumps as the torpedoes struck the hull, but only 2 exploded. The explosions hit the tanker's engine room. The ship stopped dead in the water, listing to port. Daspit moved in for the kill. With the target sitting motionless, Daspit had time to set up the perfect attack. He positioned Tenosha at 875 YRDs, directly abeam of the tanker, a 90° angle, the ideal firing position that every submarine commander trained for, the geometry that should guarantee success. At Aero 9:30, Daspit fired torpedo number 5. The torpedo ran straight and true. The crew watched its wake cut through the water like a deadly white finger reaching toward the target. That torpedo struck the hull. There was a dull thud. No explosion. Daspit could not believe what he had witnessed. He fired torpedo number 6. Hit. No explosion. Torpedo number 7. Hit. No explosion. Torpedo number 8. Hit. No explosion. Daspit called his torpedo officer into the conning tower. They examined the remaining torpedoes in the tubes. Everything appeared perfect. The torpedoes were properly maintained. The depth settings were correct. The contact exploders were armed. There was no mechanical explanation for the failures. Daspit fired torpedo number 9. Hit. No explosion. Torpedo number 10. Hit. No explosion. Torpedo number 11. Hit. No explosion. Daspit wrote in his patrol report, "This torpedo hit well after on the port side, made a splash at the side of the ship, and was then observed to have taken a right turn and to jump clear of the water about 100 ft from the stern of the tanker. I find it hard to convince myself that I saw this." By this point, a Japanese destroyer had arrived and begun depth charging. Daspit had to leave. But before diving deep to evade the destroyer, he fired his remaining 4 torpedoes. Torpedo number 12. Hit. No explosion. Torpedo number 13. Hit. No explosion. Torpedo number 14. Hit. No explosion. Torpedo number 15. Hit. No explosion. 15 torpedoes fired. 11 confirmed hits from textbook range and angle. Only 2 explosions. Daspit had 1 torpedo remaining. He made a decision that would change naval history. He would save that torpedo and bring it back to Pearl Harbor for examination. He would not waste it on a target that torpedoes apparently could not sink. Daspit set course for Pearl Harbor, writing in his log what no submarine commander ever wanted to record. He was returning with an empty bag. USS Tinanoza arrived at Pearl Harbor on August 4, 1943. Daspit went directly to Submarine Force Headquarters. Rear Admiral Charles Lockwood, who had replaced Robert English as Commander Submarines Pacific in February 1943, following English's death in a plane crash on January 21st, met him at the door. Lockwood had been expecting an angry tirade. He later wrote, "I expected a torrent of cuss words damning me. The Bureau of Ordnance, the Newport Torpedo Station, and the base torpedo shop. I could not have blamed him. 19,000-ton tankers do not grow on trees." I think Dan was so furious as to be practically speechless. But Daspit did not explode. He was beyond anger. He simply described what had happened. 15 torpedoes, 11 confirmed hits, 2 explosions. A sitting target that sailed away because American torpedoes did not work. The single torpedo Tinanoza had brought back was immediately taken to the submarine base torpedo shop. Technicians examined it thoroughly. They found nothing wrong. The torpedo was in perfect working order. According to every test, it should have exploded on impact. Lockwood knew he could not wait for board to act. They had denied the depth problem for months. They had denied the magnetic exploder problem for over a year. They would deny the dud problem until presented with evidence so overwhelming that denial became impossible. Lockwood decided to conduct his own investigation, again, without authorization, again, regulations, again at risk to his career. He ordered his gunnery and torpedo officer, Commander Art Taylor, to organize live fire tests. They would fire actual combat torpedoes with full warheads under conditions that simulated real attacks. Lieutenant Commander Swedson joined the investigation. Misson was already legendary in the submarine force. In 1939, he had led the rescue of 33 men from the sunken submarine USS Squalus. He had invented the Moms and Lung, a breathing device that saved countless lives. He understood mechanical systems. He understood testing. And he understood that the Mark 14 was killing American submariners. Taylor and Momsen scoured charts of Hawaiian waters looking for the perfect test location. They needed sheer vertical cliffs, that dropped straight into deep water with a sandy bottom where torpedoes could be recovered. They found the perfect spot on the coast of Kahului, a small uninhabited island southwest of Maui. On August 31, 1943, USS Muskellunge fired 3 torpedoes with full warheads into the cliffs of Kahului. The first 2 torpedoes exploded. The third did not. Monson personally dove into the water to examine the failed torpedo. It was broken in 2 pieces with the warhead split open. The warhead had not detonated. With extreme care, the crew hoisted the unexploded torpedo onto a barge and transported it to Pearl Harbor. After disconnecting the warhead, Momsen and his technicians disassembled the exploder mechanism. What they found was shocking. The firing pin had been released from its restraint, but it had not traveled far enough along its guide rails to strike the primer cap with sufficient force to detonate the explosive. The impact of hitting the cliff at 46 knots had crushed the delicate mechanism. The faster and harder the torpedo hit, the more likely the firing pin would jam without triggering the explosion. A perfect 90-degree hit, the ideal attack angle that submarine commanders trained for, was the most likely to produce a dud. But Masson could not test his theory by firing more expensive warheads into cliffs. Lowe approved a different approach. Art Taylor supervised the construction of a test rig. They acquired a crane from the Pearl Harbor shipyard. They filled dummy warheads with sand to match the weight of full explosives. Then they dropped the warheads from a height of 90 feet onto a steel plate positioned at various angles. 90 ft was carefully calculated. A warhead dropped from that height would strike the plate at the same velocity as a torpedo traveling at 46 knots. The results were devastating. When warheads struck the plate at 90 degrees, the perfect perpendicular hit, 70% failed to detonate. 7 out of 10 duds. When warheads struck at 45 degrees, a glancing blow, only 50% failed. The oblique hits were twice as reliable as the perfect hits. The problem was obvious. The Mark VI exploder's firing pin mechanism was too delicate. It had been designed for slower torpedoes. The Mark III exploder used in World War I torpedoes had suffered from the same problem. Impact forces would drive the firing pin sideways in its guides, jamming it before it could strike the primer. The solution had been to install a stronger spring. But when the Mark VI exploder was developed in the 1920s, the designers ignored the lessons learned from the Mark III. They created a mechanism that was even more delicate. The faster Mark I-14 traveling at 46 knots, instead of 30, generated impact forces that the firing pin mechanism could not withstand. Every submarine commander had been trained that a 90-degree shot was the ideal attack, but the 90-degree shot was the most likely to produce a dud. The Navy had been teaching submariners to use the one attack angle that was most likely to fail. Lockwood immediately sent a message to all submarines in his command. Do not fire at 90-degree angles. Fire at oblique angles, 45 briefdirt or less. The order baffled submarine commanders. It contradicted everything they had been taught. It made attacks more difficult, but it cut the dud rate in half. The message also served another purpose. It proved to the Bureau of Ordnance that the problem was real. Submarine commanders were note incompetent. The torpedoes were defective. Lockwood knew the oblique shot order was only a temporary solution. The firing pin mechanism had to be redesigned. But the Bureau of Ordnance controlled all torpedo modifications, and the Bureau was not interested in admitting another failure. So Lockwood took matters into his own hands. He ordered the submarine tender USS Holland to begin manufacturing modified firing pins. The solution was elegant. The original Mark VI exploder used a heavy steel firing pin block. Under high impact forces, this heavy block's inertia would cause the firing pin to jam. Lieutenant E.A. Johnson, under Taylor's supervision, designed a lighter firing pin block machined from aluminum alloy. The aluminum came from an unlikely source: propellers from Japanese aircraft shot down during the attack on Pearl Harbor. The irony was not lost on the submariners. They were fixing American torpedoes using metal from Japanese planes. Johnson also developed an electrical firing switch as an alternative to the mechanical firing pin. Both solutions worked. Both were relatively simple to manufacture. On September 30th, 1943, USS Barb departed Pearl Harbor on patrol with 20 torpedoes, all equipped with the modified aluminum firing pins manufactured aboard USS Holland. The results were immediate and dramatic. Barb's torpedoes worked. By mid-October, Holland had produced enough modified firing pins for all submarines departing on patrol. Nearly 2 years into the war, the United States Navy finally had a working torpedo. The transformation was immediate. In 1942, American submarines fired 1442 torpedoes and achieved limited success. Post-war analysis by the Joint Army-Navy Assessment Committee revealed the actual results were 134 ships, totaling 580,390 tons. The actual success rate was far lower than wartime estimates. In 1944, with working torpedoes, American submarines sank 492 ships, totaling 387,780 tons. In 1945, they sank 132 ships totaling 469,872 tons. The lower 1945 numbers reflected target scarcity after the successful campaign had devastated Japan's merchant marine. The Mark 114 torpedo, once fixed, became one of the most effective weapons of the Pacific War. American submarines sank 1,314 Japanese vessels, totaling 5.3 million tons. They destroyed 60% of Japan's merchant marine. They strangled Japan's supply lines. They sank 8 aircraft carriers, 1 battleship, and 11 cruisers. They accounted for 55% of all Japanese shipping losses. But this success came at a terrible cost. The submarine force suffered the highest casualty rate of any branch of the American military. 22% of submariners who went on patrol never returned. 52 submarines were lost with all hands. 55 officers and men died. Many of those deaths occurred in the first 2 years of the war, when torpedoes did not work. How many submarines were lost because their torpedoes failed at critical moments? How many submariners died because they had to make multiple attacks on targets that should have been destroyed with the first salvo? How many Japanese ships escaped to sink American vessels because submarine torpedoes were duds? The questions haunted Lockwood for the rest of his life. In September 1943, after the torpedo problems were finally solved, Lockwood described it as V-Day in submarine warfare. From September 30th, 1943 onward, American submarines were truly effective weapons. American submarines were truly effective weapons. But Lockwood never stopped thinking about what might have been. He later wrote, "Had the torpedoes been properly tested before the war, we would have entered combat with weapons that functioned. The war would have been shorter. Many lives would have been saved." Bureau never officially apologized. In their post-war analysis, the Bureau admitted that testing had been inadequate. They acknowledged that production planning had been faulty. They conceded that torpedoes were designed for meticulous small-scale manufacture that could not be scaled up for war production. The Bureau's final report declared, even with the comparatively limited funds available in peacetime, much of the work now being carried out after more than 18 months of war could and should have been completed years earlier. That the work was not done during peace or the early stages of the conflict, and that no one at the Bureau or at Newport, according to existing records, apparently questioned the inadequacy of the design without such trials, demonstrates a lack of practical understanding of the issues involved, a deficiency inconsistent with the Bureau's high standards and reflecting discredit upon both the Bureau of Ordnance and the Naval. Torpedo Station, Newport. The Chief of the Bureau therefore orders that, as a matter of permanent policy, no service torpedo or related device shall ever be accepted as standard until it has been tested under conditions simulating as closely as possible those encountered in combat. It was an extraordinary acknowledgement, but it came too late for the submariners who had perished with faulty weapons. The torpedo controversy revealed deep flaws in how the Navy developed and tested armaments. Budget concerns had taken precedence over battlefield performance. Secrecy had prevented the men who used the weapons from understanding their function. Bureaucratic arrogance had delayed fixes for problems that field commanders identified within weeks of the war's beginning. The Bureau of Ordnance had spent 2 decades developing a torpedo that failed to function. They refused to believe reports from the men risking their lives using it. They blamed submarine captains for incompetence rather than admitting design failures. And when the issues could no longer be ignored, they resisted every correction, every modification, every improvement. Charles Lockwood became the hero of the story, not because he was a gifted engineer, but because he listened to his submarine commanders. He trusted their judgment. He risked his career to conduct unauthorized trials. He bypassed official channels when bureaucracy failed. He took personal responsibility for fixing weapons that technically weren't his to fix. Most importantly, he refused to send men into battle with weapons he knew were defective. Lockwood's unsanctioned investigation at Frenchman Bay in June 1942 exposed the depth issue. His covert tests at Kahulaway in August 1943 revealed the dud problem. His improvised repair operation aboard USS Holland in September 1943 provided the solution that finally gave American submariners functioning torpedoes. Each step broke regulations. Every decision risked court-martial. Every move challenged the authority of the Bureau of Ordnance, one of the Navy's most powerful institutions. But Lockwood understood what the Bureau did not. The purpose of weapons is to work. The purpose of tests is to find flaws. The purpose of leadership is to solve problems, not deny them. By the war's end, Lockwood had risen to Vice Admiral. He attended Japan's surrender ceremony aboard USS Missouri on September 2, 1945, standing among the senior Allied commanders who defeated Japan. His submarine force had sunk more Japanese shipping than all other forces combined. The Mark 14 torpedo had become one of the Pacific's most feared weapons. But that success came from the courage of one man who refused to tolerate failure. The story of the Mark 14 torpedo. Scandal is ultimately a story about testing, or rather, the failure to test. In 1931, a new automobile cost $700. A Mark 14 torpedo cost $10,000. The Navy decided torpedoes were too expensive to destroy in trials. They tested with lightweight dummy warheads and evaluated the magnetic exploder in laboratory tanks. They conducted exactly 2 live fire tests in 1926, then sent the weapon to war. The cost of not testing was measured in failed attacks, lost submarines, dead sailors, and a war prolonged. By 1944, the U.S. was producing 150 Mark 14 torpedoes a day, with total wartime production exceeding 60,000. At $10,000 each in 1930, that equaled $600 million, about $12 billion today. Proper testing might have cost a few dozen torpedoes destroyed under realistic conditions, perhaps $500,000, less than the cost of one submarine. Instead, the Navy fought 2 years with defective weapons. Submarine commanders achieved only 20% success when they should have reached 80% or more. Japanese merchant ships that should have been sunk in 1942 kept sailing until 1944, supplying troops and fueling aircraft that killed Americans. If U.S. torpedoes had worked from December 1941, the submarine fleet could have accomplished in 1 year what it actually took 3. Japan's merchant marine would have been destroyed by 1943 instead of 1945. The war might have ended much sooner. Tens of thousands of lives could have been saved, all for the cost of proper testing. 50 torpedoes destroyed in realistic trials in 1939. $500,000 that could have saved billions of dollars and countless lives. But the Bureau of Ordnance deemed testing too costly. They were wrong. The failure to test was far more expensive. Today, the torpedo scandal is studied in military academies as a cautionary tale. It imparts several key lessons. First, systems must be tested under realistic conditions. Laboratory trials cannot replicate combat performance. Second, the users of weapons must be involved in testing and development. Submarine commanders recognize torpedo issues within weeks, yet were excluded from design discussions. Third, bureaucracies must be willing to acknowledge mistakes. The Bureau of Ordnance spent 2 years denying what was obvious in the field. Fourth, secrecy can be counterproductive. The magnetic exploder was so classified that even submarine captains were forbidden to inspect it, preventing those most familiar with the weapon from spotting flaws. Fifth, leadership demands listening, trusting expertise, and taking risks to resolve problems. Lockwood proved that real leadership means defying authority when it's wrong and refusing to endanger lives with faulty tools. By September 1943, American submarines finally had torpedoes they could rely on. The change was immediate. Crews who had endured years of failures now possessed weapons that worked. USS Tang, under Commander Richard O'Kane, achieved extraordinary results. USS Barb, equipped with modified firing pins from Holland, began a legendary combat record. Submarines hunted Japanese shipping across the Pacific, the Philippine, East China, and South China Seas, crippling Japan's logistics. By 1945, Japan was economically strangled. Its industries lacked raw materials, its cities lacked food, and its military lacked fuel. American submarines had accomplished what strategic bombing and surface battles could not. They destroyed Japan's capacity to wage war. The Mark 14 torpedo remained in service until 1980, upgraded and refined over decades, but it never would have become truly effective without Charles Lockwood's defiant investigation. One admiral who refused to accept broken weapons, one inquiry conducted against orders, one test proving what everyone already suspected. The torpedoes didn't work. Charles Lockwood died on June 6, 1967, at age 77. He rests in Golden Gate National Cemetery beside Admirals Chester Nimitz, Raymond Spruance, and Richmond Kelly Turner, all heroes of the Pacific War. Yet Lockwood's greatest victory wasn't fought at sea. It was won at Frenchman Bay, at Kahulawe, aboard the USS Holland, and in the conference rooms of Washington. It was won every time he trusted his men over bureaucracy. His legacy endures as a reminder that leadership means courage. The courage to challenge authority when lives depend on it, to conduct the impossible investigation, to fix the problems others deny, and to ensure no one goes to war with weapons that don't work. That was Charles Lockwood's impossible investigation. And that is how one admiral repaired America's broken torpedoes.